Hi guys, how are you?
Hi,
Did
Miss.
you go over the homework?
Yeah.
Yeah.
Mhm.
Okay. Did you have any questions?
Um,
Okay. And before I move on, right, Arush wanted to ask in class, right, Arush? I remember
yeah.
now.
I was just
Yeah.
reminding you.
Yeah.
Yeah.
So I was wondering if we can just advance the class timing. Krish, Parvini, can we advance it a little bit?
To what time?
To what time? To what time? We start at 7:45, right? How about maybe 6:45 to 9? How does that work? Does it work?
6 o'clock?
6 o'clock?
Okay.
6 o'clock or 6:45 is okay?
I'll have to ask my mom.
Mom, okay. Parvini, how about you?
Um, 6:45 to 9.
6:45 to 8.
I'll also check and let you know, Auntie.
Let me know. Okay. Both of you will let me know. Okay. Okay. Yeah. Both of you will let me know, but I don't see some of them. I don't know why, what's going on. Mm-hmm. Me, Parvin, okay. Arush mom is not in here. Why? Oh my gosh. Arush, did you join the class? Did you join the WhatsApp group?
No.
Oh, you have to. Otherwise, how will you get the messages? Okay, I think I've added mom. Let's get going. Hmm. Let me share my screen. So we did. Krish, were you able to go through the homework? Did you understand stuff there?
Yeah.
Okay. So we are good with asymptotes.
Mm-hmm.
Anyway, I'm planning to administer a test as well. So let's see. Let me get going with the last part of Unit 1 and the first part of Unit 2. Before you go to your school, I really want you to have a heads up on derivatives. Okay. So let's see. I wanted to go to this topic today is easier. Let's see. 1.4. I just want to ask a couple of questions on asymptotes. Let me see. I don't want this, but I want a test prep question on asymptotes. Let's see. Let me give it this to you and see. 1.3, right? Okay, how about this? I don't know if we ever did this. Okay, let's see. Actually, we didn't do. Let's see. Okay, go ahead and try this one. This is based out of asymptotes. Function. Okay, you want me to put it bigger? I can put it bigger as well. Shall I put it bigger? Are you able to see, or you want me to make it bigger? Guys, you need to tell me, guys.
Can you make it bigger, Auntie?
Yeah. 1 second. One second, guys. Oh my God, I can't believe this. 1 second. One second, guys. How do I do this? Mm. I can write it bigger. Just give a minute. I'm connecting my second monitor. Okay. So f of x will be equal to minus ax cube plus. Whenever I take it for review, it just grabs away time though. By e power of minus x minus w x cube plus w. Okay, this has a horizontal asymptote at y equal to 2, vertical asymptote at x equal to 0. This is an asymptote. We didn't do the test review questions at all. Okay. I just want to know what is the value of w minus. Can we try? Just you try, let's say. Everything is small quantity. You have to see which grows faster, right? There's a horizontal asymptote at y equal to 2 and a vertical asymptote. Let's try. If it's hard, then let's see. You're able to do it? Are you guys able to get it? If you're stuck, you have to let me know, guys. Don't just keep quiet, okay? I just want to move on at the same time, review a bit of asymptote and move on to continuity. After completing continuity, I want to get to derivatives as well today. Let's see. If you're stuck, you have to let me know, guys, please. We'll revise a few. Arush, can you go over this part on time? But most of it stuck on the vertical asymptote part. Arush, how did you get A? Can you let me know how you got A? Krish, did you get it?
I'm still working on it.
Wait,
Arush, you want?
you was the like 2.71 thing, right?
What is that?
E is like the 2.71 whatever.
Yeah, that is true. That's the Euler
Okay.
number. That's true. But you don't need it, right? Why do
Yeah.
you need it? You
I
made a
just
minor mistake, Arush. What is that? Can you let me know how you did it?
Okay. So, and I actually didn't like solve it, but like, I know that A over W equals 2 because like as it approaches infinity,
Mhm.
it'll have to like
See,
the other
vertical
thing,
asymptote is 0 means, okay?
like as x approaches infinity, the other things will become like irrelevant, and so it would just become ax cubed over wx cubed. So then
Correct.
a over w.
Right. So that becomes ax cube by wx cube. That's correct. Then
Um, so that means a over w is 2.
how do you know it's 2? Oh, okay. But what happened to the w?
What
Good, but see, nice thought. I mean, the thought process is good. The conceptual thing is good. But what happened to the w?
I can't see what you're writing. It's getting like cut off.
Oh my goodness, what guys? Okay, wait. Wait, let me see why. Hello. Wait. Let me copy this.
Okay, I got it. Yeah, I can see.
You can see?
Yeah, now I can see it.
Oh, okay. Go ahead. I moved the chat window. So ax cube by wx cube, right? What happened to the w then?
Um, what do you mean? Like,
Okay, I understand. You're saying this is too huge, correct? Okay, when x approaches infinity, that is true. Okay, that is for the horizontal asymptote you're trying to solve, because when x approaches infinity, you're going to get the horizontal asymptote. That's great. That's all great. But my question is, what happened? Okay, so you considered this ax cube by this becomes 0, so this is wx cube, so you cancel these two, then a by w will be equal to 2, right?
yeah,
Then how did you find a equal to 1?
the w minus a would have to be negative because a is bigger than w. Like that's what I thought.
Why?
Oh, because a is bigger
How do you conclude that?
because a over w is 2.
Okay.
So then that's what I thought. So that I
It
thought
can also be minus a by minus w equal to 2. I mean, I see. Okay, let me go ahead and solve it methodically. Did you get it, Krish?
Uh, I think, but can you go over it?
What's the answer?
Is it C?
Yeah, how did you get it?
Um, it took me a while to get it, and
So
I
what?
wasn't really sure if I was right though.
That's okay. Go ahead. So let's solve for the vertical asymptote. Okay, vertical asymptote at x equal to 0 means what would happen to the denominator? Vertical asymptotes happen when the linear factors of the denominator, right? So e power of minus x w x cube plus w. So it happens at x equal to 0. So clearly that's given. So can I substitute x equal to 0? So if I substitute x equal to 0, this goes off. E
Auntie,
power of,
well, I can't see what
um,
you're writing.
oh, you're not able to see, ma?
It's like
Parvini, you're not able to see?
it's like a little cut off.
Okay, wait, let me see what to do. This cut off. Okay, so I need to take a picture and then 1 second, guys. Okay, stop share, reshare. Now you're able to see?
Yeah.
Is it much better?
Mhm.
Okay, so in this case, first I'll solve for the new denominator, right? Denominator, the vertical asymptote happens at x equal to 0. So e power of 0 minus w times 0 plus w, right, will be equal to a 0. Now what happens? This goes off. E power of 0 is 1 plus w equal to a 0. W will be equal to a minus 1. Any questions there?
No.
Any questions there? Okay. So now you get w equal to minus 1. With this in place, right, would you be able to solve the next one? Meaning, we solved for vertical asymptote, right? What happened? Horizontal asymptote is equal to a 2. That means, what can I do? Which meaning for the horizontal asymptote, I have to see which grows faster, right? So can I go ahead and take on the numerator? I don't have to be bothered by any term other than that x cube. X cube also will grow smaller, will not grow as quickly as e power of. However, let me go ahead and try finding um, the x cube term is important. Let's go ahead and try that. First, let me write out this by substituting w equal to minus 1. What happens if I write w equal to minus 1? Ax cube plus bx square plus cx plus d divided by e power of minus x. This is a minus 1, right? Plus x cube minus 1. Any questions there? Any questions there? Now, which terms will be considered far more important? I use the vertical asymptote, found out w equal to minus 1. Now, I can use the horizontal asymptote. For the horizontal asymptote, either x goes to minus infinity or x goes to plus infinity, correct? How about this? Suppose if x goes to plus infinity, right? If x goes to plus infinity, what happens? Let's say x goes to plus infinity. For the horizontal asymptote, I'm saying, okay? What happens here? If x goes to plus infinity, this is going to be 1 by e power of infinity. This term is going to be 1 by e power of infinity. That's going to be almost be a 0. So that being the case, what do you have? We don't have to be bothered by any of these, but the highest term and this term is what we are bothered, because this is going to become 0. Now, minus ax cube by, what are the terms in here? This is going to become 0. So you will have x cube term majority. We don't have to be bothered by this, right? Now this and this gets cancelled, and that will be equal to minus a, and the horizontal asymptote is at a 2. So we get a equal to minus 2. With that in place, what they have asked, w minus a, right? So minus 1 minus minus 2 is a plus 1. Any questions, guys? It was complicated. Can I move on? So first use your vertical asymptote x equal to 0, put x equal to 0 and equate it to 0 and find out what is w. Then substitute w into the equation. For the horizontal asymptote, what you can do, when x tends to infinity, right, put x equal to infinity and check. Substitute the values of w as well. But the horizontal asymptote is at y equal to a, right? Y equal to 2, right? So you can equate 2 to whatever grows faster. You're only considering this. This will become 0. You don't have to consider. So you consider this. So that will be equal to, and you equate it to 2, a will be equal to minus 2. Make sense? Can I move on? Let's go ahead and review 3 more problems and then only we'll go. Let's see. This one is easy, but try, guys. These are the ones that will help a lot. Okay, let's see this one. The questions that we do after the, see this, these are based on asymptotes. Asymptotes was the last week's work. Try this one. What are the horizontal asymptotes of the graph in the xy plane? Horizontal asymptote means you have to consider what? X equal to infinity and x equal to minus infinity. Try both, find out. What happens? Horizontal asymptote can happen only when x equal to minus infinity or x equal to infinity, right? Okay. Now, in both the cases, you have to evaluate and see what is the answer here. That you can do, I think, this one. It's not a hard one. Let me know if you need help. Mano, are you able to do? Mano, are you showing work in the homework? Huh?
No, there's not enough space to show.
That is a little concerning to me, you know.
I mean, most of it I am able to do without work. So.
Okay. Some of them did not actually. Done. Guys, are you finding it tough? Then I will do. Otherwise, you have to let me know whether you did or not.
I set my answer.
That's nice, Mano. Oh, this is a good one actually. Let's see this one. Now you can go ahead and do this one. You don't have to wait. That's nice, Krish. Arush, that's nice. Parvini, where are we on that one?
I sent you the answer, Miss Priya.
Oh, really? Okay, okay. You can go ahead with the next one. Not really, Parvini. You did not do one of the parts. When x tends to plus infinity, what happens? When x tends to minus infinity, what happens? Now, did you substitute and check?
Yeah.
See, 5 plus 2 power of minus infinity by 1 minus 2 power of minus infinity. Did you try this?
Yeah.
So what did you get on that?
I got -1.
When it is equal to which one did I give you? I don't. Okay. Okay. So you got y equal to what, ma? So this one, what did you get?
-1.
This one? X equal to positive infinity means then that becomes a different story. Okay. Y equal to a negative infinity means that becomes a different story. So when x tends to infinity, what happens? 2 power of infinity is huge, right? X is in power is huge, right? Divided by minus 2 power of infinity, right? So what happens here? 2 power of infinity, 2 power of infinity cancels out and then you get a -1, right? So that is one asymptote. When x equal to minus infinity, what happens? So 5 plus 1 by 2 power of infinity is too big a number. So this becomes 0 divided by 1 minus 1 by 2 power of infinity. This becomes 0. So that is 5. So y equal to -1, y equal to 5. Those two are the asymptotes. You should always compare minus infinity and plus infinity for horizontal asymptotes. Make sense?
Yeah. Thank
Yeah.
you.
Then the next one. I don't know what is the answer for this one. Let's see. What did I give you? X square. Did you get it? Arush, honestly, I don't know the answer for that one. That's interesting. Arush, did you do?
Hey, a
Got
hole
it?
doesn't count as an asymptote, right?
What is it, ma?
Like, can you count a hole as an asymptote or no?
No, no. They both are different types of discontinuities. That's what we are going to learn today. No, whole is not an asymptote.
Okay.
Oh, I didn't know if it was a hole or asymptote.
Which of the following asymptotes? You have to consider, yeah, you have to consider x is equal to infinity, x equal to minus infinity, right, guys? Krish, you're able to take it forward?
Like, what do you mean by that?
No, no. Are you able to proceed with the problem?
Oh, I finished this one.
Okay. What answer did you get? Manav, did you get the answer?
I'm still thinking.
Krish, Krish, that seems okay. X, okay. How did you get that, Krish?
Which one? For
This
the
one, the one that's on the board. So you need to find the asymptotes, right? How did you find?
So for the horizontal asymptote, I did on the top one I put infinity, but then if they're the same, x squared and over x squared, it's just gonna be what's it called? 0
Yeah,
or
x
1?
square over
Sorry,
x
1.
square, okay. When x is greater than or equal to 0, right?
Yeah.
Mm-hmm.
And then when it's less than, if you plug in negative infinity, it will give
So that's
you
going to be x square by x square, okay, which is equal to 1. Okay, then.
And then if you plug into negative infinity on the bottom, it will give you negative infinity over 0. So
Negative infinity over 0, correct. Okay.
so that isn't anything.
True, there is, yeah, okay.
And then for the vertical asymptote on the top, you take whatever's on the
One second.
bottom.
These are horizontal asymptotes, right?
Yeah.
Okay. So horizontal asymptote is y equal to 1 is the only one, right? Then
And then
for the vertical asymptotes,
for the vertical asymptote, you
equate
take,
this to 0.
yeah, and then you square root that,
So
and
x
you
will be
get
equal to
1.
plus or minus 1, right?
Oh, yeah. I
No,
forgot
no,
the
no,
plus
you're
1.
right. No, 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 you're right. X equal to plus or minus 1. But then what is this? This holds good only when x is greater than or equal to 0. So x equal to plus 1 only is valid, correct? So what happens now? X equal to
So,
minus 1 is not valid,
yeah.
right? But coming to this one, right? Equate your denominator to 0 for your vertical asymptote. Can e power of x ever be equal to 0? It's an exponential function, right? It can never be equal to 0, right? So what do I understand from there? There is none. There is no horizontal asymptote there. So what is the answer? X equal to plus 1 and y equal to 1. Does that make sense? I get C as the answer. Any questions?
For the negative infinity horizontal asymptote, Could
Negative.
you say it's negative infinity divided by almost like a number really close to zero? So it's
Once
just
again,
negative infinity again?
you want to do negative infinity for horizontal asymptote, huh?
Yeah, like if you for the second one you can say negative infinity over like 0 point like so a number like really close to zero, like would you like make it infinity? That's what I thought.
Exactly. So here, negative infinity, e power of negative infinity, correct, ma?
Yeah,
I'm sorry, this will be e power of negative infinity. E power of negative infinity is 1 by e power of infinity. This is too big a number, correct?
yeah,
So this is going to be a very, very, very small number, right?
yeah.
So what would happen? Uh,
No, if it's bigger but small then it's nothing.
what is it?
Like if it's a big number over a small number, it's nothing.
Yeah, it is
The
going to go
small
to
number.
negative infinity, right?
Yeah, it's a small number then.
Yeah, it's going to go down. There is no horizontal asymptote, right?
Yeah,
So there is no horizontal asymptote here. There is only one horizontal asymptote here. Makes sense?
yeah,
Uh, okay. So then, so y equal to 1 is the horizontal asymptote. The vertical asymptote is x equal to plus or minus 1, but then only plus 1 is valid because x is greater than or equal to 0.
x equals 1 is a whole, so I ignored it.
X equal to?
The x equals negative 1 is a whole, so I just ignored it.
Oh, yeah. See, yeah, you can ignore it, and moreover, x is greater than or equal to 0, only this function holds good. X less than 0, this function holds good, right?
Yeah,
Even if you consider that function, right, what happens? X is less than 0. So if x is less than 0, you have to consider that function, right? So
yeah,
e power of x when x is less than 0 will tend to go to a 0, right?
yeah.
Does that make sense?
Yeah, because like it's going closer to 0 more
Will
than.
be a very small number, right?
Yeah. So
Ah,
it's a small number. So it's a small number over a small number.
it's a small
Negative infinity over small number.
for the vertical asymptote, huh?
The horizontal.
Mano, we are discussing this or this. I'm not understanding which one do you want to discuss? Horizontal asymptote or vertical asymptote?
Or no, I'm talking about horizontal for the x over e power x.
Oh, horizontal asymptote over x over e power of x. Okay.
Yeah.
So here what happens is x is very small. Basically, x is very small when compared to e power of x, right? Now let's see if it goes to minus infinity, you want to, meaning a negative part you want to discuss, right? So this
Yeah.
would be negative infinity by e power of negative infinity. This will be a very small number, correct?
Yeah.
As a result, this one will tend to go to negative infinity. There is no horizontal asymptote there, right? Correct. It's just going to negative infinity. So this is no longer
Oh.
an asymptote.
Oh, so if it goes to infinity, there's or infinity or negative infinity, there's no asymptote.
There's no horizontal asymptote there.
Or just no horizontal.
Yeah. Got it?
Okay. Yeah.
Okay. Can I move on?
Yeah. Yeah.
Okay. How about this? I think we are reviewing too much. Let's see one more maybe. How about this? Okay, this is a good one. Okay. Again, these are just based out of asymptotes, guys. Try this one. You can do it quickly. It will be wonderful. Last one. I think we did some of this last week, though. That's what I'm thinking. I don't know. Okay, go ahead. I'll give you one more if you want to. F of x equal to 2x cube or square on, I don't know, plus 3x plus 1 divided by 2 power of x. That's the second one, okay. Answer this question. You know what? I don't know whether it's square or cubed. That's so bad. I think it's cubed. Go ahead. So for vertical asymptote, you're going to equate the denominator to 0. For horizontal asymptote, you have to check x equal to minus infinity and infinity. So there are two problems on the board. I just want the answer. Krish, that's correct. Can you go to the next one? Parvini, that's correct. Arush, that's correct. Manu, that's correct. So can we go to the second one? We don't need to discuss this, I think. Okay, let's discuss this. F of x equal to 2x cube plus 3x plus 1 divided by 2 power of x. We are going to find out which of the... Oh, I did not ask you the question. So, which of the following statements is true? That's the question. What is true? What is true if it is a horizontal asymptote at y equal to 1? I don't know. 2x cube by 2 power of x, right? That's the majority part for the horizontal asymptote. X cube is so less. 2 power of x is so high. Plus infinity and minus infinity evaluate. What would happen? Minus infinity is not a horizontal asymptote, I think. So 1 by a very big number will be almost a small number. So it will tend to infinity. Okay. Vertical asymptote, what happens? Oh yeah, it's a 2 power of x function. It will never reach 0. That's right, Arush. Krish, that's right. Parvini, that's right. Mano, did you get this one?
Yeah.
What is the answer?
B.
Yeah, let's keep moving, please. Okay, now let's go to continuity. Okay. What did I do? Okay. Let me cover the next one. Okay. We need to do test problems on that as well. This one is pretty simple, provided we understand. Let's see. Okay. So what type of a function is this? What type of a function is this? So can I call this as continuous? Can I call this a continuous function?
Yeah.
Yeah.
Not
Okay.
the second one.
Not the second one. But you know what? Here I can call it as continuous in its domain. Continuous in its domain. When you consider negative values as your domain, this function is still continuous. When you consider positive values as your domain, the function is still continuous. However, when you consider the whole function, you cannot call it a continuous function because of the asymptote. So what are the things that makes a function not continuous? So let's see. First, we need to define continuity, right? So let's define continuity. There are a couple of theorems or some definitions which we really need to know. Okay, so let's define continuity at x equal to c. Okay, how we have to definition of continuity. How do we define continuity? First of all, a function for a function f of x to be continuous, right? Let's see. For a function f of x to be called continuous, at x equal to c, the following should be satisfied. There are three conditions, okay? This is the formal definition of continuity, okay? There are three conditions that needs to be met. One is f of c is defined. First and foremost, f of c should be defined. Okay, should not be, does not exist, okay? And then limit extending to c, f of x exists. Limit extending to C, f of x exists. And then the last one, limit extending to C, f of x equal to f of C. Are we clear? This is the formal definition of continuity. It's so important. It will carry you through. Okay, we'll do problems on this. So all the three conditions, every time you want to define a continuous function, you have to see, hey, is my f of c defined? And then limit extending to c, f of x exists, and then that is equal to f of c. Can I move on? Okay, now we understood functions that are continuous or continuous on their domain, correct? So let's move on with a little bit. I just want to understand, guys, these functions. Do you remember these functions? I just want to make sure whether you remember these functions. What are these types of functions? First one is what? First one is what type of function? Arush, you tell me. What is the first type of function? First function. What is this function called?
Quartic?
Quartic? No.
Square root?
You know, which is square root?
The second one? It's like
Second one is square root. Okay, good.
Yeah.
So f of x equal, I just want to understand. Square root means, yeah, this is correct. Okay. This one, the first one? Guys,
1 over x.
1 over x.
Oh, yeah.
Yeah, it's a reciprocal function or a rational odd function, correct? How about this?
Exponential.
Yep, f of x equal to exponential growth is what I would say. Okay, this one?
Logarithmic.
Logarithmic. Okay, this one?
Sinusoidal.
Sinusoidal. Yeah, it can be cos or sin. Okay, that's nice. How about this one? Can I call it polynomial function?
Yeah.
Yeah. Okay, that's all I wanted to know. Okay, it's just a revision. Now, we will define the different types of discontinuities in a function. Okay. We're discussing continuous functions. So we defined continuity. Now types of discontinuities we'll discuss. You know what? In pre-calculus honors, we will discuss in pre-calculus honors this one. Okay. Types of discontinuities and nuities, sorry. What are the types of discontinuities? One is, right? Holes, right? Second one can be an asymptote. And then the last one is jump. This has to be vertical. And then a jump discontinuity. Make sense? Now, this one is a removable discontinuity, please. This one is a removable discontinuity. Okay. Holes are called removable discontinuities. Do you understand what are these? One is, let's say there is a function. This is this, right? Only at that point, the function is not defined, but continues thereafter. Then it's a hole there. For that x value, you don't have a y value in the graph. Asymptote, you already know. It can be like this, right? So vertical asymptotes, you already know. Holes are otherwise called as removable discontinuity. What is a jump discontinuity? Suppose at a particular point, the function comes like this and then jumps, then goes like this. This is jump discontinuity. Are we good with this? Are we good with this? Okay.
Yeah.
Let's go ahead and find out. Okay. We are going to have functions and then we are going to find the discontinuities and their corresponding x values. Okay, the different types of discontinuities you have to identify in a function and their corresponding x values. Okay, let's see. Square minus 8x plus 12 square minus 8x plus 12 divided by x square plus 3x minus 10. X square plus 3x minus 10. This is your function. Find all discontinuities and find all x and their corresponding discontinuities. Or I should say the other way. Find all discontinuities. And their x values. Can you do that for me? We'll do 3 maybe. Okay, this is number 1. Number 2, this one should be easy. See, find all discontinuities means there are only 3 types of discontinuity. One is jump discontinuity. There's not going to be any jump discontinuity in this, but there can be vertical asymptotes or holes in this. Okay, that's easy for you to find. It's just a rational function, right? Because polynomial in the numerator, polynomial in the denominator. Then let's see this one. Suppose if I give you the second type of function, this function is a little different. So here you're going to do the same thing. Third function, this is a piecewise function, x square minus 2x plus 1. Let's see. X square minus 2x plus 1. For the piecewise function, it's going to be a little different. X plus 2, 2 power of x. So let's find this. Let's try this one, guys. Find all the types of discontinuities for these 3 problems. Let's see. Okay, let me know if you want me to do this on the board. This is, you factorize this. So let me give you clues easily. So there are only 3 types of discontinuity. So definitely this will have vertical asymptotes and holes if any. Jump discontinuity won't be there. Here, here what can it be? What are the possibilities here? For the second one, if first one you solve the first one, then we can go to the second one too. That's also fine. The function is only, see, this is square root function, right? So it is not a continuous function, but continuous in its domain, right? So you'll have to write those values. Where it is discontinuous, you need to write, that's all. For the third one, it's a piecewise function. So as a result, you need to check these 2 points. The -1 point you need to check, and then x equal to 2 point you need to check whether it is continuous or not. How do you find whether it is continuous or not? Remember the 3 definitions we said, right? So let's see. You need to see whether there is a jump discontinuity between these. -1 substitute and see. Here 2 you substitute and see. That itself will tell you whether there is a jump discontinuity since it's a piecewise function. If I'm not making sense, you have to raise and tell. Oh, wow. Nice job, Arush. Parvini, nice, ma. Go ahead. Manav and Krish, I would like to get your answers too.
I'm almost done.
Mhm. So things are being given in different word formats, that's all. If it was algebra 2, they would have asked you to do, oh, find out the holes and vertical asymptotes for the first one. For the second one, tell where it is defined, they would have asked. For the piecewise function, maybe graph this piecewise function, they would have asked. Here, the question is a little bit different. Find all the types of discontinuities and their corresponding x values. Manav, you getting it, Manav? Third one is what I'm more bothered about than anything else. And please let me know, guys, whether we can have the class from what time to what time did we discuss? I would like to finish this class by 8 p.m. Let me know. You wanted, Arush, what did you ask for? Sorry, I'm asking you again.
Like the class being moved earlier.
Yeah,
Like,
yeah. What time you said?
like as like 6 or anytime after.
Okay, yeah. 6 or 6:30, guys. Just let me know.
Yeah.
6:30 as well works.
And before this, I think wait, are we moving the class to different time?
Oh, you can't, Manav?
Wait, what was the other time? Is it?
6 or 6:30
No, I have another class at that time.
at that time?
Yeah.
Mm,
I could do like Tuesday or Thursday, 6 to 6:30 for now.
yeah, Thursday.
I mean Tuesday or Thursday is fine.
I'm filled with classes on Tuesday, Thursday, guys. Monday as well, I have full classes. Friday, I have full. Wednesday is the only free day for me, or excluding your class. So, Arush, what is not working for you, Arush? He's looks like Manav is not able to do. What is there a conflict for you with the current time, Arush?
Yeah, and like we're trying to schedule something after, but like, and if he can't, then it's okay, I guess.
Manav, what is the earliest time you can come? See, I want to help you out, guys. Whatever works for all of us, fine. Tell me, Manav, what is the earliest time?
Maybe if we're going earlier, maybe I mean if we do like I mean if we started like 6, I mean if we start at 7, I'll just be like a bit late then. Like I'll come at like 7:45.
You'll come in
So
with
I mean
7:45 your time.
I
Oh,
have I have a tennis class in 2 hours.
oh, okay, okay. 5 to 7, huh?
Yeah.
Okay.
From 5:30
5
to 7:30.
oh, 5:30 to 7:30.
Mm-hmm.
Wow. Okay, Arush, I will talk to your mom and see. Then I'll come back, guys, to this class. Or we need to move to a different day, huh? I don't know what day. Yeah, I can check for Tuesdays. Does Tuesday work for you all?
Yeah, Tuesday like
How about you,
Tuesday evening.
Krish,
Yeah, that's
Arush?
what Tuesday is good.
Krish, Arush, Parvini?
Tuesday I can do like after like 3.
After 3, yeah, okay.
No, like anytime after 3.
How about you, Krish and Parvini? Tuesday works? See, I need to move another class. Then only I can commit to this class. I'll check. Tuesday, does it
Um,
work, Krish?
it may work, but for like maybe next week and the week after, it may not work. Just
Oh,
for like,
okay. Okay,
yeah.
okay. How about you, Parvini?
Cause I have another class on the other days, like except for Wednesday, so I'll check and let you know.
Oh, wow, wonderful. Okay, okay. Just keep me posted, guys, whatever, okay? Yeah, each of you keep me posted what works and then we'll conclude with something. Okay, now,
Auntie,
the third one seems incorrect. Yeah, go ahead.
what time for Tuesday?
Tuesday night It has to be Tuesday, 6:30 to. See, Tuesday night has to be 1 second, guys. Tuesday night has to be my time 6:30 to 7:30. Abhina, your time 5:30 to 5:15 to 6:30. Makes sense, huh? Tuesday means we have to go with that. Okay, so okay, we'll see, guys. I will put down some options. Okay, so now jump. Okay, see, there is a jump discontinuity at x equal to -1. That's all, right?
I was just saying like it went from this to this.
Okay.
Like it went
Yeah,
from
yeah.
y equals 0 to
Yeah,
1.
great. Yeah. So you all got this easy. Okay, so you know the types of discontinuities and how to find them. Now, when you want to find domain restrictions of functions, when you want to find out domain restrictions of functions, I don't know if you remember this. Let's say f of x equal to x minus 5 by x plus 1. How do you find out domain restrictions of functions is what we want to understand. Two different things, okay? One is functions with denominators. One is when the function is inside radicals. How do you find out domain restrictions? How do you find out the domain restrictions? One is if you have functions with denominator can never be equal to 0. So x plus 1 is never equal to 0. X is never equal to -1. Does it make sense? Number one. Number two, if it is inside a radical, whatever is inside a radical is greater than or equal to 0, because inside the radical nothing can be less than 0. So 7x is greater than or equal to -3. X is greater than or equal to -3 by 7. Any questions, guys? For domain restrictions, you need to remember how to find out domain restrictions. This is the only way to find out. If you have denominators, they should not be equal to 0. Radicals means whatever is inside the radical should be greater than or equal to 0. Okay. Now, what else? How about this? We did discuss, right? I gave you two problems. Now I'm going to give you two problems and ask you some questions. Let's see. Let me see if I can ask you this. How about this? Let's see this one. F of x equal to 3x by x root of x plus 5. I want the domain restriction on this. Then maybe g of x equal to 5 by 2 minus root x. Just find out the domain restrictions. Then we'll move on to the last part of this continuity. After this, what? The last part is so important, guys. You all already know the concept, but they put in some names for it and define something. That is far more important. Okay, the last part is very important. I'm going to deal with it. Then we'll do some problems on all of these. Go ahead and find the domain restrictions.
Do we include any folds?
No, or just the domain restriction. You don't need just the domain restrictions, meaning.
Like with the holes, you have to put it around it. So.
What do you mean by that? I didn't get you.
Like for a rational function, like if there's a hole, like you have to like write it. If there's a hole at x equals 4, you have to do x is greater than 4, and x is less than 4 in between 0 and 4. It's like you have to write it in between all the asymptotes and everything else.
Okay, go ahead and give me everything. Let me see.
Okay.
Are you talking about x equal to 0 on the first function?
Yeah.
Yeah, x is not equal to 0 for sure. See, there are three things that need to be taken care of. Okay, the denominator can't be 0. X can't be 0. Right? And then what? Square root of x plus 5 can't be 0. The last thing is it's a radical function as well. So what do? X plus 5 is greater than or equal to 0. So 3 things you need to work out.
Yep.
So yeah, one is x not equal to 0. This one, how do you solve? Here, square both sides. What happens? X plus 5 is not equal to 0. So x is not equal to minus 5. That is the second thing. The third thing, x is greater than or equal to minus 5. Now, this equal to will disappear because x is not equal to minus 5. So the restrictions are x not equal to 0 and x greater than minus 5. Any questions, guys? Krish, are you with me? Arush, are you with me?
Yeah.
Okay. For the second function, let me see. G of x will be equal to 5 by 2 minus root x. It has a denominator and there is a radical. Let's see. It has a denominator, right? 2 minus root x can't be equal to 0. That is the first thing. Second thing is there is a radical. Whatever is inside the radical should be greater than or equal to 0. So this is already done. Here 2 is not equal to square root of x. What happens here? Square both sides. X is not equal to 4. Any questions, guys? Okay. Finally, we go to the most important part. Intermediate value theorem. This theorem holds good for, we are talking about continuity, right? Only continuous functions. So important, guys. Intermediate value theorem. Okay. Think about a polynomial function. Cut paste the graph for this one. Okay. Think about a function like this. I'm going to discuss a function like this. It's a continuous function, right? You know what I'm going to do? I'm going to cut the graph in the sense I'm going to cut this part of the graph. Let's say I cut this part of the graph. Okay. I'm going to cut this part of the graph. And I'm going to assume this is A, this is B. Then this would be f of B, this would be f of A. Any questions there, guys? I'm just going to cut this part of the graph. Okay. And I'm going to define this intermediate value theorem. The concept you already know, but it's given out as a theorem to you right now. Okay, let's see. This one is pretty easy and something you know, but we are going to apply and do something about it. Okay. So see here, the same thing I did here, right? F of A. F of A is the y value at x equal to A. This is x equal to A. This is x equal to B, correct? This is the y value at B. This is the y value at A. Now, what does the intermediate value theorem say? If f is continuous, over this A to B, right? If f is continuous from A to B, then what happens? Every value between f of A and f of B, any y value between f of A and f of B, you see, any y value between f of A and f of B exists in this graph if it is continuous, right? And that has to be between A and B x interval. Any questions, guys? Is it making sense? It's not a big one. You already know the concept, but we are just trying to understand what is IVT. IVT is so important, okay? So it's a continuous function. I just take 2. This is A, this is B. And I define the y values as f of B, f of A. Now, what does it say? This function is a continuous function, right? For the interval A to B. For this interval A to B, it's a continuous function. When, if it's a continuous function, then any value, any y value between f of A and f of B, right, will always exist. It has to exist, right? If it doesn't exist, then it is not a continuous function. It will exist, and that y value will correspond to an x value between A and B. Did you get it? Not a hard one though, but it is very useful. Okay, I'll show you one application of it. We'll do one application for it, okay? How about this? Let's try to understand. Okay, here. Let's say f of x, let me give you one function, x cube minus 2x minus 5. Okay, now let's find out f of 1. Let's find out f of 2. Let's find out f of 3. Okay, now f of 1, if I want to find out, this is f of 1 minus 6. F of 2, if I want to find out, 8 minus 4 minus 5 is a minus 1. F of 3, 3 is a 9, is a 27, minus 6 minus 5. 27 minus 11 is 16. Okay. Now, let me ask you the last question. Okay. Does this function have a 0? Does this function have a 0? You can use IVT to answer. Does this function have a 0? Let me plot this function. F of 1 is a minus 6. F of 1 is a minus 6. F of 2 is a minus 1. F of 3 is a 16. What do you think about it? We don't know how this function goes, right? We don't know. It can be like this, this. It can go through this and then again go through this and somehow goes here. Or it can just be a function like this. We don't know how the shape it's taking. It can just be like this. They are just asking, does this function have a 0? Yes, no, anybody?
And it
Yeah.
has to, right?
Yes, right? How? Why?
Because it crosses the x-axis.
True, but then how will you say using IVT? Consider this as A point, consider this as B point. We said, right, this is a continuous function and 0 comes in between. Do you see? 0 line comes in between these 2 points. So if this is a continuous function, okay, this is a continuous function. So basically this is a continuous function, it's a cubic function, right? It's a continuous function. However, we already understood that this was minus 1 and this is 16, right? So it changed from negative to positive. So it should have crossed the 0 point. If this was a continuous function, 0 lies between these two, right? 0, y equal to 0 lies between minus 1 and 6. So there has to be a 0 between x equal to 2 and x equal to 3. It switches from negative to positive. So by IVT, there has to be a 0 between 2 and 3. X equal to 2 and 3. Any questions? Okay. Now let's go to do some problems. I'm able to do only one topic. That's not great, guys, but let's see. They're moving slowly. Let's see. How about this? Okay. We'll try this one. Some of it are easy. This is a good one. How about this? This is a nice one. Let's see. 1 second, guys. The other one, what I wanted to do was this one. I don't know. This graph is so hard. Let's see. Can I minimize this? Okay, we have a graph. Okay, how about this? First do this one. Second, I'll get you the function. I'll get you the problem. This is a good one. Go ahead and do this one. Which of the following function f of x is continuous at x equal to 4? This you can do. Just continue based on, we discuss continuous functions, right? So Oh yeah, that's a good one too. Yeah. These two. Yeah. See, point discontinuity. What is a point discontinuity? It is a very sophisticated way of calling what. What can point discontinuity be? We did not discuss the concept of point discontinuity, right? Not for this question. What is a point discontinuity, guys? What is a point discontinuity? Anybody? Arush, you know? Point discontinuity is basically a hole, guys. Does that make sense? Point discontinuity is basically a hole. Okay, the next one I really want you guys to solve this one. You know what? This one. Oh my gosh. Okay. Just do the first one. We'll do the second one. Let's do the first one. And then we'll do the second one. Oh my. What did I do? For which value of k is the following function continuous at x equal to 4? You just need to find out if the function has to be continuous at x equal to 4, right? What should happen? The first function should be equal to the second function. So equate it and find out the value for k. K has to be what? Krish, are you able to get the first one? Parvini, are you able to, ma?
I'm solving it.
The first one is an easy one, guys. I don't know. Let me check. I really don't know what is the answer for that one. Point discontinuity is a whole, I said. So, actually, I don't have the answer on that one. Let me see.
I don't get it. My answer isn't one of the options.
Okay. See, that involves some. Oh, this one. This one is an easier one. Let's see. Okay, let's see now. Sine pi by x, right? So we have to compare at x equal to 4, right? Pi by 4 will be equal to k. 4 is the point, problem point, right? 4 by 2. What is sine pi by 4?
Root 2 over 2.
Root 2 by 2 equal to k. What is this? Root 4 is 2 by root 2. So multiply by root 2, multiply by root 2, rationalize the denominator. So what happens? Root 2 by 2 will be equal to k times 2 root 2 by 2. 2 and 2 will get cancelled. Root 2 will get cancelled. I'm getting k equal to half. That's what you got, right, Krish? I got, yeah, k equal to half. Manav, Arush, did you get it? Arush,
Kind of.
where did you not understand? Please tell me.
Okay, so I got that at 4 has to equal 1, right?
4 has to
Equal 1.
What do you mean by that?
Because like sine pi by 2 is
Sine pi by 4,
sine
right?
pi by x.
Yeah. See, instead of x,
Yeah,
see,
so
you're going to evaluate continuity for x equal to 4 point, right?
yeah, so it's
So
pi
just
by 4.
uh-huh.
Oh, I see what I did wrong. I
You
thought pi by 4 was 90, not 45.
you got it?
Yeah.
Okay, Manav, did you get it?
Yeah, I think I thought the x was a pi.
Parvini, did you understand?
Yeah.
Okay, then let's move on to the second one. I really want to do one complicated problem. Maybe we can do it as review next class. That's fine, but with this we'll go. You want me to make it bigger or smaller? Are you able to see the graph, guys? Are you able to see the graph?
Yeah.
Okay, which of the following statements is true about f? F is undefined at x equal to 1. That's not correct. F is very much defined at x equal to 1. It's equal to a 3. F is defined but not continuous at x equal to 2. It is very much continuous. The three conditions get satisfied. F is defined and continuous at x equal to 3. Which one is correct? This one is an easy one, right? Which one is correct? I'm thinking this is the only one that's correct, because it's undefined at x equal to 1. That's not correct. It is very much defined at x equal to 1.
Isn't the answer none of them?
Oh, none of these, huh?
Because x equals 2,
Oh,
x equals
sorry, but
4.
not continuous. I didn't see, ma. I didn't see.
Okay.
I'm sorry. Yes. No, I didn't see the not. Okay. So at x equal to 2, it is very much continuous. See, all the three get satisfied. So this is not correct. F is defined. F is defined and it's not continuous at x equal to 3. So none of these statements. Can I move on? Okay. Shall we stop here, guys? Or shall I give you one complicated problem? So that way we are done with continuity. And I'll also give a unit 1 review after this. I really want that hard problem. Let me see. Give me 1 second, okay? Oh, this is a good one. This is a good one. Okay, let's see. Please, for problems like these, you have to graph. Without graphing, you won't get your answers. Try graphing that. With that, I think we can log off. Let's see. Maybe one more. See, f of 0, it is continuous in the closed interval 0 to 4. So let's draw it out, guys. Drawing is the only way out. F of 0 is 1. F of 1 is a 2. F of 2 is a 0. F of 3 is a minus 3. F of 4 is a plus 3. What do we do about this? I didn't mean to draw like that. What is that? Okay. Let me put it down here maybe. Yeah. I don't know what is that line coming through. I didn't mean to draw the line. Go ahead. So that's the point there, right? So the function can be anything. It can be like this. We don't know, but it comes here. Then what happens? Then somehow it's going through this. And then it might also be going through, like, so many things can happen for the function, but we know just these points. So what can you conclude? Which of the following statements about the zeros between the 0 and 4? This is 4 point. F has exactly 1 0. Does it have exactly 1 0? This is based on IVT, guys. Exactly 1 0. Does it have only 1 0? What do you all think?
But Miss Priya,
Yeah.
isn't it talking about just 0,4? Sorry. I'm sorry. I didn't see that properly.
This one?
Yeah, I didn't see that properly.
Yeah, between 0 to 4, right? That interval, 0 included, 4 included. Does it have only 1 0? Definitely there is 1 0. Definitely there is 1 0. But is it exactly 1 0? See, IVT between these two, consider this as A point, this as B point. One is negative, one is positive. What does it mean? There is definitely a 0 between these 2 points, correct? Has more than 1 0. Has more than 1 0, has more than 2 zeros. We don't know. Nobody says that it has more than 2 zeros. It can be more, has exactly 2 zeros. We can't say that. It can have more than 2 zeros. It can have. So what is all true? There is some truth to this. So which is true? You can send the answer. If you get it correctly, you can leave. Yes, Krish. Good job. See you next week,
Thank you.
Krish, but I'll work out a timing for you all. I'll check with Arush mom as well.
Okay, thank you. Bye.
Bye, ma. Did you send the answer, Manav?
Yeah, it was 2 zeros because
Is it exactly 2 zeros? We don't know, right? See, we have not been given in between. We have not been given the in between values. It can be more than, right? Meaning, Manav, nobody said that the function is going like this, right? We are only given points. So it could have been like this as well, right, Manav? You see what I mean? Makes sense, huh?
yeah. In algebra, in like pre-calc algebra 2, we would have thought it was 2. I would have
Yeah,
thought.
but then see, they've given only points. We don't know the fate of the graph.
Yeah.
So whatever you're sure, only you can answer, right?
Yeah.
So which is correct?
It is exactly 1 0, but there can be more. Is what
No, there are definitely 2 zeros, right?
like you can have you have 1 0 for sure, and then there could be some more. That's what I thought.
Yeah, has more than one. So what is the only thing that can be correct? Has more than 1 0 between the interval 0, 4. Does that make sense?
Yeah.
Yeah, we cannot say it has more than 2 zeros. We cannot say it has exactly 2 zeros. Definitely, it's not exactly 1 0 because by IVT between 3 and 4, there is a 0. So what you can say is F has more than 1 0 in the interval 0, 4.
Oh,
Can I stop here?
yeah.
Yes.
There are some difficult problems, guys, in the homework. Anyway, I'm going to give it to you. Please work through the problems. Let me know if you don't understand something, bring it back to class. Okay. There will also be a review posted for Unit 1. Okay. Next week, we'll start differentiation.
Okay.
Okay.
Thank you. Bye.
Hi, guys.
Bye,
Arush,
thank
should I
you.
Okay, he's gone.